This is paper 4, and it is March 2022, latest paper. So I have already solved for you. So look at the first question. Question is, the point P in the figure 1.1 represent the point mass. Draw lines to represent the gravitational field around P. So remember, for the isolated mass, for the isolated neutral object, gravitational field is radial, equally spaced at the surface of the sphere, and all field lines are directed towards the center of the sphere. Suppose this is the sphere, and we have to draw at least 4 lines like this, equally spaced. Gravitational field is attractive, so we will draw arrows towards the center of the sphere. So you can draw like this, at least 4, 6, 7, 8, 9, 10, it's up to you, but 4 are sufficient. Next, the moon in a circular orbit around the planet. Explain why the path of the moon is circular. Look, in orbit, centripetal force is provided by the gravitational force. So the gravitational force is providing centripetal force. And the centripetal force is perpendicular to the velocity of the moon in the orbit. Thus, the path is circular. So gravitational force is providing the centripetal force, and the centripetal force is perpendicular in making 90-degree angle the velocity of the object. Thus, the path is circular. So do remember, for the circular path, it is very important that the angle between the force and the velocity remains 90 degrees. Now, the next one. Many moons are in circular orbit around the planet. The angular velocity of the moon is omega when the orbit of the moon has a radius r about the planet. Figure shows the variation of r cube and omega square with these moons. Look at this, r cube at the y-axis and 1 over omega square at the x-axis. So show that the mass m of the planet is given by the expression m is equal to gradient of this graph divided by g. So where g is the gravitational constant. Look, in the orbit, gravitational force is providing the centripetal force. And the gravitational force is g m capital M over r square, mean mass of the planet, mass of the moon divided by radius of the orbit, and m r omega square centripetal force. A small m cancelled, g m over r cube is omega square, so gm is equal to r cube omega square. So now look at this. The gradient of this is equal to r cube divided by 1 divided by omega square, which can be written as r cube divided by 1 over omega square. I mean, it is r cube omega square. I mean, this is the gradient. The gradient is r cube omega square. So the gradient is r cube omega square. So this is the gradient. So we can write this m is equal to r cube omega square divided by g. This is gradient. So hence the gradient divided by capital G is the mass of the planet. It is proved. Next, use the figure and explanation in C to show that the mass m of the planet is 1 into 10 power 26. Okay, so m is equal to gradient divided by g. So first we calculate the gradient from the graph. So look at this. Suppose we take these coordinates, this one, this one. So value is 2 into 10 power 23 vertically. And at the x-axis, this is 3 into 10 power 7. So the gradient y-axis over x-axis, it is coming 6.67 into 10 power 15. This is the gradient. I took this point. So 6.67 10 power 15, the gradient, divide the value of g 6.67 10 power minus 11. And then the answer is coming this, hence it is proved. Next, determine the speed of the moon in orbit around the planet with an orbital radius of 1.2 10 power 8. So look again, the gravitational force is providing a centripetal force in the orbit because the weight is negligible. Actual equation is gravitational force is equal to weight plus centripetal. But in the orbit, this weight is negligible because G is inversely proportional to D square due to large value of the G, D, the G is very small, so we ignore it in the orbit. So Fg is equal to Fc. So Gmm over R square, mv square over R. So when m cancelled and one R cancelled, so V is equal to Gm over R under root, G value. Mass we have calculated, the radius is given here. So after calculation, the answer is this 7,500 meter per second. This is the speed. Now move to the next question. A fixed mass of the ideal gas has a volume V and the pressure P. The gas undergoes a cycle of changes X to Y, Y to Z, and Z to X. The table shows for the data rho, volume, temperature for X, Y, Z. State the change in internal energy for the one complete cycle. Do remember, for one complete cycle, the change of energy is zero. So answer is zero. Now calculate the amount of the gas. So for this, we will consider this gas X, its pressure, its volume, its temperature. So PV is equal to nRT, pressure is given. 1.5 into 10 power 5, this one. And this volume is given 4.2 10 power minus 3. Moles number required are 8.31 and temperature this. And after calculation, you will get this 0.14 moles. Next, complete the table. Use the spaces below for any working. Look, for the second one, pressure multiplied volume is equal to nRT. So the volume is equal to nRT over P. So mole same. R value is 8.31. And next, the temperature. Look at this. This is 230 for the Y and divided by the pressure, 1.5 into 10 power 5. So you will get the answer, and it is coming 1.8 volume. And why this 1.5? Look at this from X to Y in the table. X to Y. This line is horizontal. It means the pressure is constant. So that's why same pressure is used for this one, 1.5. Now, by using the PV is equal to nRT, we can calculate the volume. Here, PV is equal to nRT, nRT over P. This is N, R, and T temperature divided by the same pressure. Then you will get the answer, which is coming approximately 1.8 into 10 power minus 3. So we will substitute here 1.8. Now, from Y to Z, look at this. From Y to Z, this one, this vertical line, it means the volume is same. For the Z, we will substitute the same volume, 1.8, hence the table is completed. Next, the first law of thermodynamics for a system may be represented by the equation delta U Q plus W. State with reference to the system what is meant by delta U. This is positive delta U. So increase in internal energy of the system. Then positive Q, heat energy supplied to the system. And positive W mean work done on the system during compression. Explain how the first law of thermodynamics applies to the change from Z to X. Due to increase in the volume, work is done by the system. I mean, expansion of the gas. And expansion causes work done by the gas. So cooling occurs due to the cooling effect, temperature decreases. Hence, internal energy decreases. So Z2X, look at this. Pressure is inversely proportional to volume, Z2X. Volume is increasing. There is expansion of the gas. And the pressure is decreasing to the work done by the gas. So cooling effect, hence the internal energy decreases. Next, question number 3 is, a small wooden block of the mass m floats in the water. Wooden block mass m, this block is not completely dipped in the water. The top face of the block is horizontal and has the area A. The density of the water is rho. State the names of the two forces acting on the block. One is the weight and other is the upthrust of the displaced liquid. The block is now displaced downward as shown in the figure so that the surface of the water is high up the block. State and explain the direction of the resultant forces acting on the block in this position. Look, when it is dipped further into the water, displaced water volume increases, upthrust increases, weight remains same. So when the upthrust is greater than weight, then definitely the resultant force acting upward. Because the weight acting down, thrust acts up, but due to more depth, more displaced water, thrust becomes greater than weight. Hence, the resultant force is in the direction of the larger force. So it is upward. Resultant force is upward. Next, the block is now released so that it oscillates vertically. The resultant force F acting the block is given by F is equal to A rho Gx, where G is gravitational field strength, X is the vertical displacement of the block. From the equilibrium, explain why the oscillation of the block are simple harmonic. Look, area of the block, constant. G is constant. Density of the water constant. Mass of the block constant. So when all these 4 quantities are constant, then A directly proportional to X with negative sign. And this is the definition of the simple harmonic motion. Thus, A directly proportional to negative X mean both are directly proportional, but opposite in direction. So this is simple harmonic motion. Next, show that the angular frequency omega is this. Look, this is resultant force. It's given here. And the resultant force produces acceleration. So we can write ma is equal to minus a rho and this g and x. So acceleration is equal to minus rho ag over mx, but the actual equation is a is equal to minus x omega square. So this is a negative sign is here, x is this. It means this whole fraction is representing omega square. So by comparison, omega square is rho g a over m, hence omega is equal to a rho g over m under root. So it's proved. Next, the block is now placed in liquid with greater density. The block is displaced and released so that it oscillates vertically. The variation with displacement x of the acceleration a of the block is measured for the first half oscillation. Okay, this is acceleration displacement graph. Explain why the maximum negative displacement of the block is not equal to the maximum positive displacement. Mean amplitude decreasing. So amplitude is decreasing due to resistive forces, which is the drag force of the liquid, which results in the damping. So due to damping, amplitude is decreasing, and the reason for the damping is the loss of energy, and because there is a viscous drag. Next, the mass of the block is 0.57. Determine the decrease in the internal energy of the oscillation for the first half oscillation. So change in energy is equal to 1/2 m omega square. First amplitude minus square minus second amplitude square. But do remember this omega square is the gradient of acceleration against displacement graph, because A is equal to minus x omega square. So omega square is equal to A over x. So first we calculate the gradient of this graph. So this portion suppose this vertical value, this one is 2.3, and this horizontal distance is 0.02. So this is the gradient. So it is 0.57. So 1 by 2, sorry, 1 by 2, mass is 0.7, not gradient. So 1 by 2, the mass is given here 0.57. And this omega square is equal to gradient, mean 2.3 at the y-axis, divided by the x-axis, 0.02. And then the first side amplitude, this one. Look at this. This amplitude is 0.02. And the other side, this amplitude is 0.16. So for the first amplitude, 0.02 square. For the second, 0.016 square. And after calculation, you will get this answer as 4.7, 10 power minus 3. Now move to the next one, number 4. State what is represented by the electric field lines. So field lines are representing direction of force experienced by positive test charge in the electric field. Now, 2-point charges P and Q are placed 0.120 meter apart as shown. Look, this is P, this is Q, this is Q. The charge of P is plus 4 nanocoulomb and the charge of Q is minus 7.2 nanocoulomb. Determine the distance P of the point of the line joining the two charges where electric potential is 0. Suppose this is the point, this one, and its distance is x. Then the distance from the Q will be 0.12 minus x, 0.12 minus x, total distance minus x. So here the potential is 0, mean one of the potential is positive and the other potential is negative, so the resultant is 0. So we will write here potential due to P and the potential due to Q both are equal. So potential formula 1 over 4 pi epsilon naught Q divided by D. So 1 over 4 pi epsilon naught Q divided by D, you can write D this X is equal to 1 over 4 pi epsilon naught Q charge divided by the second distance is 0.12 minus X. Now 1 over 4 pi epsilon naught, both sides cancelled, cross multiply. This charge is equal to 4 nano, 4 into 10 power minus 9 divided by X. And this charge is 7.2 10 power minus 9 divided by 0.12x. Now cross multiply 4 times this 10 power minus 9, 10 power minus 9 cancelled. So 4 times 0.12 minus x and 7.2x. And after calculation, you will get the answer 0.043. This is the distance from the P at which the resultant potential is 0. Next, state and explain without calculation whether the electric field strength is 0 at the same point at which the electric potential is 0. Answer is no, because electric field strength between positive and negative charge have the same direction. Look, if this is positive charge, this is negative. So look, it is directed in one direction. There is no chance of 0 because field line are directed from positive to negative. So answer is no. Next, an electron is placed at the point x equidistant from P and Q as shown. So this is P, this is Q. Here the charge is 4 nano, here the charge is 7. So when x point is this, electron is here. Due to small charge, this electron is attracted by the small force F. And due to the large, this negative charge, the electron is repelled with a large force, this one. So the resultant of these two forces, and this F1 and this F2, so suppose we add this portion of the force here, then this line is the resultant. This is the direction of the motion of the electron. after experiencing the resultant force from the both charges. So you have to first draw forces. It is attracted by the positive charge. It is repelled by the negative charge. The negative charge force is too large as compared to this positive charge because this is -7, this is +4. So this vector is large, this vector is small. Now add them according to head to tail rule. The one force in this direction, other in this direction. This will be the result. This is the resultant motion. So question number 5, I will divide this paper into 4 videos. So this is the first video for question number 1, 2, 3, and 4.